Alright, so warm up number 60. Start with number 1. See how we do with number 1. By now we should be experts at this, yeah? Alright, number 1. Square root of 41. And it says round your answer to the nearest 10. So square root of 41 is approximately, layman, 6.4. Hands, have you got that? That is correct, yes. So how did we get there? So 41 is in between 36 and what? 49, yes. So if you subtract this from that is 5. Subtract that from that, it's 13. So 5 divided by 13 does not fit. Add a 0, that's 3. 39, subtract, that's 11. Add a 0. Fit in there 8 times, that's 104. Subtract, that's 6. And I'll stop right there. This 8 makes this 3 into a what? A 4. Alright? Number 2. Says graph f of x equals x cubed without a table. So by now, hopefully I've been hammering this as much as I could, and I hope you see that all functions that we've been covering have to go through which point? 0, 0, which are our point of origin. So if this is a cubic, our vertex goes through 0, 0, but it looks like this. This is my f of x. Okay? But they give us a transformation according to the parameters given here, which is a negative 1, b is 1, h is negative 5, and k is negative 2. So if I rewrite this, this is g of x equals negative f of x plus 5 cubed minus 2. So we have 3 parameters still in there. Tell your neighbor what those 3 are going to do to this original function. What are those 3 going to do? So according to this transformation, what's our new vertex? What's our new vertex, Noor? Negative 5, negative 2. So I go to negative 5, 1, 2, 3, 4, 5, negative 2, 1, 2. So my new vertex, instead of being here, now it's over here. Which means I already did h and k according to the vertex, yes? What's the only thing that's missing? This negative. Everyone, what is that going to do now to the function? Flip it. It's going to invert it. So instead of doing this, I'm going to do that. And this is my g of x. Alright. Number 3a. Is it a standard form? Yes. Is there a GCF? No. But now we have 4 terms. How do we factor that? Group, that is correct. Group and group. Then you find GCF, GCF, da-da-da, da-da-da. So my factors are what? Lewis. Oh, help him out, Christian. X squared very good, plus 5 and x plus 3. Hands, have you got that? Okay, that is correct. And that's factor by graph, by grouping, yeah? All right, let's go to number 3b. Let me go over 3b just to make sure that we're on the same page. Here it goes. Is there a GCF? No. Is it a standard form? Yes. So I group these 2 and these 2. What's GCF for these 2 right here? 64 and x cubed. That leaves us with x plus 1. What's GCF for these 2 right here? Negative 27. That leaves us with x plus 1. So, what's the same here and here? x plus 1, yes. And what do we have left? 64x cubed minus 27. Am I done? No. I remember when we came to these, I said, okay guys, you need to memorize the identities, right? And I'm pretty sure you did memorize the identities, yes? You guys remember these, yeah? Okay, good. Yeah, because that's number 20 on the final. So let's see. What's the identity? Let's see if I remember. I think I gave you guys, yeah, it was x cubed minus y cubed, which is the same as x minus y times x squared plus xy plus y squared. Remember these? Yeah? Yeah, Mr. Q. You're saying, but I don't have that, Mr. Q. Well, how do you know? Well, let's check. Can I take the cube root of this one? Yeah, what number times itself 3 times gives us 64? 4, and that one is x. So in other words, we can write this as what? 4x cubed, yes? Minus, what's the cube root of 27? 3, or in other words, we can write it as 3 cubed. So, does this look like this? Yes, but instead of 4x, over here on the identity we should have x, and instead of y we should have what? 3, yes? So far so good? So I'm just going to rewrite this using these values. So here we go. Parentheses, x minus y. So what do I write? 4x minus 3, yes? Parentheses, what's next? X squared. So what do I write? 4x squared plus x times y. 4x times 3, y squared. 3 squared. So, 4x minus 3, this is 16x squared plus 12x plus 9. These are my factors, but don't forget the BFF, x plus 1. Factors. Once again, that was like number 21 on the study guide or the final. And the other one was like number 20. Yes? Okay. All right, let's go to number 4. Long division, our favorite. Yes? Yes, Mr. Q. All right, step 1. Is it in standard form? Let's see. 3rd degree, 2nd degree, 1st degree, 0 degree. Yes. Anything missing? No. 1st degree, 0 degree. Standard form? Yes. Anything missing? No. So then I write x cubed, 7x squared, 16x plus 12, and all that divided by x plus 2. All right, so here we go. What number times x gives me x cubed? Everyone? Everyone? Okay, let me repeat that again. What times x gives me x cubed? X squared, yeah, so that is x squared times x is x cubed. X squared times 2, that's 2x. We're going to subtract, and what does that do? We distribute here and here, so this cancels. 7x squared minus 2x, that's 5x squared, and this is a square. 5x squared. Bring down the next term. What number times x gives me 5x squared? Positive 5x, yes. So 5x times x, that's 5x squared. 5x times 2, that's 10x. We're going to subtract, which means we distribute the negative here and here. This cancels. That leaves us with 6x. Bring down the 12. Last, what number times x gives me 6x? 6, positive 6. So this is 6 times x, that's 6x. 6 times 2, that's 12. We're going to subtract. So this becomes negative, negative. That means these cancel, so we're left with 0 remainder. So what's my answer? My answer is x squared plus 5x plus 6. That's my quotient. Coming back, yes? For some of you? Okay, good. That's number 21 on the final. And yesterday we used synthetic division. That's number 22 on the final. Yeah. Thank you, Mr. Q. You're welcome. Yeah, I'm giving you a lot of extra practice. Let's go to number 5. It says graph. So let's get our coordinate plane set. There it is. Now I'm going to graph y equals negative 6. So that's 1, 2, 3, 4, 5, 6, which is down here, and a straight line going through that point. There you go. All right, and x equals 2. X equals 2, that means 1, 2, point, and a line going through straight through that point. There it is. Okay. All right. Copy the agenda for today. Warm-up number 60. We're still doing the completing the cumulative review, and our home plate tonight is to study. Alright, so no asynchronous code. Those of you that are watching online, basically if you're a part of the class, you can go and get the study guide on Canvas. So everybody knows where to get that. That was due yesterday. Today you still work on that. And yeah, let's get started. Let me pause this really quick. Anyways, just wanted to make a point with that, yeah. Alright. Right, Miguel? Right? Alright, so yesterday we started with a study guide, and I asked you to go and do the first 3 by yourself, compared to the work that we did in class to make sure that you got it. Yes? Good job. Appreciate it. And the video was uploaded, by the way. Yes? Okay, good. Here we go. Number 1 looked like this. We covered domain and range. We covered and behavior. Yes? Yes, Mr. Q. From there we went to number 2. We covered plotting points, graphing curves, and interval notation. Okay. From there we went to transformations. Using f of x equals x squared. The original, we made a table for the original f of x. Then we described the different transformations just like I asked you guys to do here in class. But on paper, you needed to write exactly what each transformation did. There it is. Then we made a table for which parameter? Parameter A. We plotted that. We didn't label this one g of x because we weren't done. We needed to do what at the end? H and k. And then the last one we labeled g of x. Then we got to this one. Did we get to this one? Yes? All right, so then we left off on this one. We're going to continue on this one. So go to your notes. For those of you that weren't here, you can use the study guide. In the study guide, you already have this graph. And write the table right next to the graph with values -2, -1, 0, 1, 2 for the domain, and for f of x, -8, -1, 0, 1, 8. So, oh, sorry. So we're here. So in passing, really quick, the general rule or general form of our transformations is g of x equals a times f of 1 over b x minus h plus k. That's the general rule, yes? And we've been using that rule just to do our different transformations, especially on the warm-ups, yes? So look at this and tell your neighbor what each of these parameters does to the original function. Talk it over to your neighbor. What does each of those parameters do to the original function? Okay, so what's the only parameter that they give us, everyone? B, that is correct, which is this 4 right here. It's a whole number, which will do what to our original function? It's going to stretch it horizontally. So picture that. Picture me grabbing it from here and stretching it horizontally. Can you picture it? Does it move the vertex anywhere else? No, because there's no h and there's no k. Therefore, we need a table to find out how it's going to stretch. So we write here next to that x f of 1/4 x cubed. All right, I'm going to zoom in so I can show you the work. Here it goes. So my first value that I'm going to use is -2. Okay? So for the purpose of saving space here, I'm not going to use the f function because I know it's a function. So I'm going to start with a parentheses. And I got what? 1/4 times x. What is x now? -2 cubed. What is 2 times 1/4? That's -2/4 cubed. Can I simplify that fraction? Yes, -1/2 cubed. All right, here we go. Numerator. What is -1 times -1 times -1? -1. What is 2 times 2 times 2? 8. Do the second value. The second value is going to be what? -1. And once again, parentheses, 1/4 times -1 cubed. That leaves us with -1/4 cubed. So let's see. What is -1 times -1 times -1? -1 over. What is 4 times 4 times 4? 64. Damn, Andy, let's go. You remind me of me in kindergarten. Here we go. 0, 0. So what's our next value? 1. Find me the value for that one once you do the work, and then for 2. Give some time. Copying. Alright, so therefore you should have done 1/4 times 1 cubed, which is 1/4 cubed, which is 1 over 64. Yes? And the last one, 1/4 times 2 cubed, which is 2/4 cubed, which simplified is 1/2 cubed, which is 1 over 8. We good? Yeah? All right, so let's graph that. We're going to graph -2, -1/8, negative 1, negative 1/64th, you're like, oh man, that's very small, Mr. Q, I know. 0, 0, 1, 1/64th, and 2, 1/8. So let me zoom out really quick. All right, here we go. Negative 2, negative 1/8. Negative 2, negative 1/8 is about right there. Next one. Negative 1, negative 1/64th. That one is so small that it's almost on the x-axis. Negative 1, negative 1/64th is very close to the line right there of the x-axis. You guys see that? Like pretty very close. Next one is what? 0, 0. And notice the vertex did not move. It's still on 0, 0 because we didn't have h and k. And then 1, 1/64th. 1, 1/64th, almost on the x-axis, and 2, 1, 1/8. So, curve it a little bit so you can see that it's a cubic, and this is my g of x. So, did it do according to what we predicted? Did it stretch horizontally? Yeah, imagine me grabbing it from the top and bottom and just stretch it like that. There it is. All right, so here we go. What do we do for 3 and 4? Let me go back to the previous one. The previous one, we made a table for the original function, graphed the original function, then made a table for the parameter a to see the stretch or compress. We did that, and then at the end we did h and k, and then we labeled our last transformation. For this one that we just did, same thing. We started with a table for the original, and then this one was b. We made a table to find the stretch and compress. And what if it would have had h and k at the end? What do we do at the end with all those points? Move it according to h and k. From 1 to 5, how comfortable are you with these so far? Yeah. Is it coming back? Yeah? Yes, Mr. Q. All right, good. All right, so that was number 4. All right, let's move on. Let's go to number 5. Let's see. 1, 2, 3, 4, 5. It says find the inverse function of the original function and then use composition to verify. I'm going to zoom in. You can use your study guide. It's right in front of you. Let's do this one together. So let's see if you remember what to do with these. What is the first thing we do once we are given a function in order to write the inverse? What do we do? Miguel, what do we do? Did we do that? Change this to y. Very good. Y equals 3/4 x minus 1. And now that we change f of x to 1, we solve for x. So what do we do from there, Brooke? Subadd, yes, subadd 1. There it is. So we got y plus 1 equals 3/4 x. Andrew, to get rid of the 3/4, what do we do? Yeah, multiply times 4 over 3, or the reciprocal. Yeah, and we do that to both sides. 4 over 3. So this is 4 times 3 is 12. 12 over 12 is a giant 1. So that leaves us with x. Okay. Let's multiply this 4 in here. We get 4y plus 4 and all that over 3. So we already solved for x. But is that the inverse? No, tell your neighbor what makes it the inverse. What's going to make it the inverse? Lenny, go. Switch the variables x and y, yes. So this becomes 4x plus 4 over 3. And all that equal to y. Now that's the inverse, but can we leave it in that notation? No, Mr. Q, because the original was function notation. So I'm going to change now the y again to function notation, but I write it how? F inverse of x equals to, what do we have over here? 4x plus 4 over 3. And this is my inverse. Is it coming back, yes? Okay. Alright, now here goes the fun part. This is where some of you struggled last time. Last time I said we need to check to see that this is the inverse of that. How do we check, Mr. Q? Well, we first start with the original function, f of x. And what do? Well, if we start with f of x, that means that if I substitute in here into the original f of x, if I substitute the inverse, at the end I should get equal to x. That's what the point is of checking. Once again, what am I going to substitute? The inverse. Okay, so here we go. So I'm going to start with the original one. What is my original? F of x. So what is f of x? All of this, yes? So I'm going to write it here, but without the x. I'm going to open parentheses. So f inverse equals 3/4 parentheses minus 1. Alright, so what am I going to substitute in here and here? I'm going to substitute the inverse. Now for those of you that get confused with this, I'm going to use a highlighter to show you. This portion goes right here, and this portion goes right there. So I would write f inverse of x, and over here I would write 4x plus 4 over 3. And now all I have left is to simplify the right side, but in order for me to do that work without any worry from the left side, because we don't do anything on the left side, I just write a couple more of these just so that I use as a label as to what I'm working with. I'm working with the inverse of x, substituted in there for f of x. Once again, why am I doing this on the left? So that we understand we don't do anything on the left. Alright, let's focus on the right side. Let's see. Can I distribute 3/4 in here? Yes. What is 3 times 4x? 3 times 4, that's 12x plus 12 over, and the denominators, what is 4 times 3? 12. Bring down the negative 1. Next. Here we go. What is 12x divided by 12? 1x. What is 12 divided by 12? 1. Then you bring down the negative 1. Can we combine stuff? Yes, right here. What is that? 0, and we're left with x. Did we end up with what we needed to check? Yes. F inverse of x equals to x. There it is. But am I done? No, Mr. Q. Now I need to check the opposite. I'm going to start with the inverse of x. But instead of having an x in there to equal to x, what am I going to substitute in here, guys? F of x, yes. Which means I need to use now my inverse. I'm going to bring it over here. And I'm going to write f inverse parentheses equals 4 parentheses plus 4 over 3. Yes? Yes, Mr. Q. So what am I going to substitute in here and here? Well, I'm going to use my highlighters to show you. Here we go. Now I'm going to substitute f of x in here. And then I'm going to substitute, let's see, Can you guys see the baby blue? Yeah? And that goes right there. Alright, so then I get f of x right there, and 3/4 x minus 1. Alright, so in order to start simplifying the right side, let's do a couple more of these on the left side so that we know what we're working with and we don't have to worry about the left. So we are working with substituting f of x. Okay. Now let's get to work. Here we go. I'm going to work on the numerator first. Yes? Here it goes. So just to show you that I'm focused on the numerator, I'm going to leave the denominator by itself. There it is. Focus on the numerator. So what is 4 times 3? 12 over 4x. Yes. What is 4 times negative 1? Negative 4. And then when you bring down the plus 4. Alright, can I combine stuff, guys? Yeah, what is negative 4 and positive 4? 0. Okay. So what is 12 divided by 4? 3, and that leaves us with 3x over 3. Yeah, does everybody see we went from here to here? Yeah. So, what do we get at the end? What is 3 over 3? 1x. Did we get what we needed to get started with? Yes, there it is. Alright, so now we need to graph. Let's graph the original one. Our original one is f of x equals 3/4 x minus 1. And then I'm going to graph this one, but I need to write it in the same format, in slope-intercept form. Look what I'm going to write. F inverse of x equals 4/3 x. What did I get 4/3 x, guys? Well, from here. 4x divided by 3 is the same as 4/3 x, yes? And what is 4 divided by 3? 4 divided by 3 is 1.3. If you don't see it, make sure you box it so you know where we got this from to get that. 4 divided by 3 is 1.3. Alright, now that we have those, let's graph that. Here we go. I'm going to graph the original in blue just so that I can have a different color. This one. Where do we start, guys? At negative 1. That's my y-intercept. Negative 1 is right there. And what is my slope? My slope is 3 up, 4 to the right. So I'm going to go 1, 2, 3, 1, 2, 3, 4. Now that I have that, I can graph my line. Alright, let me zoom out. And let me graph my line. Extend it as much as you can going to those 2 points, please. There it is. Alright. So that was the original. Let me graph the inverse. So what is the y-intercept? The y-intercept is 1.3. Let me zoom in. 1.3, 1 1/3 is about right there. And what is my slope? 4 steps up, 3 to the right. So I go from here, 1, 2, 3, 4, and 3 to the right. 1, 2, 3. So it's here and there, and then graph your line going through those 2 points. Let me zoom out. Look at that beauty. Humor, yeah, like sure, yeah. Do they look like they're reflecting from y equals x? Yeah, it looks like a reflection. Is it coming back? Yes. From 1 to 5, I'll come to borrow you with these. Yeah, 5 fourths, okay. Alright, and I think we can cover one last one. Here we go. This one, copy that inequality and in the absolute value equation over here to the right. Negative 8 times the absolute value, negative x minus 6, plus 10 equal to 2. Now, quick recap before you leave, because I know the bell's going to ring in a little bit. When we first covered absolute value, once again, the second week of the year, I said we use this symbol because it's the distance from here to here, from one place to another, which means it's covering distances. That means that the absolute value is always what? A positive. So what happens if you have an absolute value, once you leave it by itself, equal to a negative? What would you say? No solution, right? And then at the end, you just solve this by writing your two equations. We'll continue with that tomorrow. Have a good one, guys. It's your home play. Once again, work on that study guide. Enjoy it. Make it a math family night or something. See you guys tomorrow. Bye. Drink water.